Hello, sir. Hello.
Yes, so let me share my screen.
Sir, I'm not getting that yesterday's SQL file, sir. So where?
Yes. Yesterday's मैंने share ही नहीं किया ना yesterday.
Okay.
See, I told you no class timing is 8:45. Don't join from 8:30. Start joining from 8:45. Everyone.
Okay.
I think Vijay and Lakshmi and these two guys are new. Vijay and Lakshmi, the class timing is 8:45 because some student are they were having problem joining 8:30.
Okay, sir. Okay, fine.
So make sure you join from 8:45. Yeah. Okay. So yesterday we have seen the difference for the transactional database, this one difference between transactional database and data warehouse database, right? Now there is one more point when it comes to parameter. First parameter was user, second is entity, third is your technology side, then there is front end technology, whether in in your transactional database you have web server, browser for interaction. These things we have discussed, right? Now let me add one more point when it comes to difference between OLAP and OLTP. OLAP and OLTP is nothing but the difference between transactional database and data warehouse. I'll tell you, this transactional database is known as OLTP, online transactional processing, and this is known as OLAP, online analytical processing, right? And you have database design based on integrity issues and normalization. Here we have based on dimensional modeling. Based on dimensional model. Then the next point is when it comes to database design, here you don't have any star schema, so no star schema. Here you have to create a star schema. Creation of star schema is needed. Third point. Third point is nature of access. It is crude, which is create, retrieve, update, and delete. Create, retrieve, update, and delete. And of course, you retrieve existing data. You what is crude means it includes all operation. You add new data, you modify existing data, you delete existing data, and of course you retrieve existing data. So this we refer in database parlance as crude operation: create, retrieve, update, and delete. In data warehouse, we generally don't do all of these operations. The focus is primarily on retrieving because it's not transactional in nature. I don't log in to add a data warehouse, add into a data warehouse database to purchase a product, right? You log into the transaction system. So given that there is a significant difference in the way you approach working with a data warehouse as opposed to working with a transactional database, to summarize broadly, the transactional system are referred to as OLTP, online transactional processing system, and the analytic side of these things they are referred to as online analytical system, OLAP. So this one to remember the difference. So that is the one way to remember the difference between transactional database and data warehouse database. So it is also known as, this point I already have said. This is also known as transactional database, also known as OLTP, and this is also known as OLAP. So what is OLTP? Online transaction processing system. Online analytical processing system. Right. So that's all we have for the difference as we have seen this. Now I'll share this file on your drive at the end of the session so that you can revise it whenever it is required. Right. Uh, all right. So next is ACTL process. You'll in the next segment we'll learn about the select, extract, transform, and load. So what is that? Let's understand this SCTL. Now let us spend some time trying to understand the life cycle of a analytics application. Whenever we want to analyze data, we are more often than not working with data from multiple data sources. There could be an inventory application, which is one data source. That could be another application which is giving me, let's say, my live cell information, and that could be another data source, and so on. So we have multiple data sources from which we can extract the information. So we could be dealing with multiple data sources which you want to use as part of your analysis. But it turns out that you cannot take all data in these multiple data sources directly for your analysis. So which is why we try to draw a line and say that data sources are all there on one side. I want to get my data for my analytics into the right side, which is typically can be called as data warehouse. So when we talk about this data warehouse is can be viewed as a collection of an integrated collection of data that is amenable for analysis. As I was saying, it is very difficult to take the data sources as it is from this data sources, move them into my data warehouse. So what we generally do is we select, we do, or we put it through a specific set of processes, which I will abbreviate as ETL, which I abbreviate it as ETL. So S in ETL stands for select. SETL. S in uh, ETL stands for select, extract, transform, and load. So this is generally also referred to just as ETL process, but I slip in an extra S there, and I will explain what that means. So what we'll do is, let's take out a figure. DS1, data source 1, data source 2. So what we generally do is we put it through a specific set of processes, which I will be abbreviated as ETL. So SETL stands for select, extract, transform, and load. So this is generally also referred to as the ETL process, but I slip in an extra S. I'll explain what that means. So what we are now saying is that these data sources go through this ETL process. These are the data sources. It go through ETL process before it ends up into data warehouse, and then you can start your analysis. So let us quickly look at what this four terms stands for. Select the current inventory levels of only these categories of data. I can say that from my sales data source, I need to extract the sales information of only this category of data. So select means select current inventory levels of only these categories of data. I can say that from my sales data source, I need to extract the sales information. Suppose from my sales data source, I need to extract the sales information of only this category of data. So what we are trying to say here is, for our analysis, we may not be needing all the data from all the data sources. So the select stage of the ETL process is just a paper identification of what data you need from each of those data sources. Of course, in practice, it is a lot more complicated than merely writing it down on paper, because in typically large enterprise, you may have to contact the owners of that data. You may have to convince them to share that particular data for your analysis, and you have to work with their IT team to figure it out how they are going to send you the data. Will they be sending it through FTP or whatever mechanism, right? So that's a very complicated process, but it has to be done. So I have simplified it, saying select is nothing but identification of the data that you want to analyze. Now then comes to extract. Extract is the process of actually connecting to that particular data source and pulling out the data for your further processing. You have extract now. Extract process of extract is a process of actually connecting to that particular data source and pulling out the data for your processor. So for example, we have identified that from the inventory management database, I want the inventory information for one specific category called as electronics. So that is the identification part. But now on a day-to-day basis, for example, I need to contact to the inventory database. I need to identify the inventory levels of that particular electronics category data. I had to extract it. So this process of something that we have to do on a periodic basis, typically, this is done on a daily basis, right? So we have to keep extracting that particular data. Well, you might be wondering, so we have extracted the data. And what is stopping me from jumping into analysis, right? So why there is need of transformation? But before that, let us write down this. Suppose from the inventory management system, from the inventory management system, a database, let us call it as database. I want the inventory information for one specific category. I want the inventory information for one specific category called electronics. So that is the identification part. But nowadays, now on day-to-day basis, for example, I need to connect to the inventory database. I need to identify the inventory levels of that particular electronics category data. So I had to extract it. So this is this process something that we have to do on a periodic day-to-day basis. This extract process. Now, why? What? Uh, like you might have observed that we have extracted the data, and what is stopping us from jumping into analysis is transform process. Why there is need of transform? So what we say is the data that we have extracted may not be readily amenable for analysis. For example, it might be containing lots of abbreviation. It might be having currency data. It might in some different currency. You want to analyze it in a different currency, right? Suppose you have data, uh, it might contain some lot of abbreviation. It might be having currency data, suppose. So you might have data in dollars and you want to analyze it in Indian rupees. So there is need of transformation, right? Then maybe you want to analyze it in US dollars. So when the data is not readily usable after extraction, you will put it through the next stage, which is called as transform, right? There can be a number of example. Let's say weight is in kg or weight is in pound. You want to analyze it in Indian unit, that is kg. Or volume of water is in gallon. You want to analyze it in liter. So how do you do this? You put this process to transform your all of your data. Transform all of your data. So transform is nothing but modifying the extracted data for various reasons, right? So modification can be for currency conversion.
विपुल और एक बार बता दो ट्रांसफॉर्म के बारे में.
Modification can be, yeah, I'll tell you just can be currency conversion. For example, to standardize my data, for example, names of city might have been abbreviated in many different ways. Suppose names of the city are in abbreviation: BGR, Bombay, Delhi, DEL, right? You want to spell this in different ways. So you put that into your transformation. As simple as this. So you want to spell them uniformly. So that is the transformation, and finally comes the time which we call it as load. So transformation is nothing but this, as you can observe in front of your screen. Transformation means transforming your data into suitable format in which you want. तो सपोज आपके पास डेटा है वो डॉलर्स में, करेंसी डेटा आपको इंडियन रुपीज में चाहिए, तो वो आप एक्सट्रैक्ट किया हुआ डेटा आप डायरेक्टली एनालिसिस के लिए लोड नहीं कर सकते ना. You have to transform that data, put some transformation. Transformation matlab converting dollar into rupees, pound into kg, of the city into whole entire city, something like that, right? Yes or no?
Yes.
Yes.
So now I'm happy with the transformation that I've done to the data. I have extracted all the data I want. I have made all the necessary transformation that I want. Once I'm getting ready to load the data, that is when I push my data, change to my data warehouse. So this is in a nutshell is a transform, select, extract, transform, and load process, which almost always precedes the data warehouse analysis. And I should also tell you that it can be as complicated as I told you about picking up the phone, getting into an agreement, and so on. It might as well be as simple as receiving an Excel file over a mail for you. So the extraction part is a logical activity, and depending upon the data that you are working with, and depending upon the environment you are working with, may be coming up in different shapes and forms. Similarly, the transformation activity as well can happen in many different ways, right? As I said, if it is the data, if the data is being received by you in Excel, then you might probably be writing a whole bunch of Excel formulae to transform the data, to message the data with the form that you want, right? On the other hand, if you are using any other tool, now there are many transformation tools that are available. For example, we have Tableau, which has got tool called Tableau preparation, Tableau prep. So we have Pentaho, something like that, Pentaho. Uh, so which we can use to transform that particular data and finally load as well on the right hand side. Yeah,
We can do this in Power Query also, right? In Excel.
yeah, Power BI also you can do. I'm just adding few some of
Power
the tools.
Excel Power Query.
Yes, 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 yes. Yeah.
Okay.
So we have shown as a data warehouse again can take many different forms. Uh, it can take form of Excel file. Then I can fire take the file that load into Tableau or do lots of analysis, which you probably have done already, right? On the other hand, for which for we can also be imagining that the right hand side is an SQL database, and if you are loading that particular database into a relational SQL database, then we can fire a lot of queries using SQL. So that is your select, extract, transform, and load process for you. So file can be anything. It can be SQL, Power BI file, Power Query, or Tableau file. You can load that file to do some sort of analysis, or to do some sort of preparation, extraction, and then what you have to do is you have to load that data into your data warehouse. So right hand side on this diagram, we have a data warehouse. If you see, so that is your this summarizes your entire SETL process, right? All right. Now next is very important part. Next is your entity constraint or constraint. Next is your entity constraints. Now you already have learned about the CTL process, which is used to ingest data into a schema and perform operations on it. But can we add just any value that we want to a schema, or are there any constraint to maintain the sanctity of the database schema? So put yourself in the place of a data analyst at Uber. A database at Uber has several tables which record several details, such as details on the rider, the driver, and the vehicle used, and the transaction details. Each such table has several related attributes which describe it in detail. Now consider the rider table. You go through the values entered in a column that contains the fares for each ride. It would be right for you to expect that the fares can have a maximum of 4 digit. A fare more than even 5,000 can also be there on your table. So would you raise a concern? 5,000 fare would raise a concern, right? This is definitely an outlier, because if you're traveling only in city, only in particular city, your fare cannot be 5,000, right? So this is definitely an outlier and needs to be replaced with a right value, ensuring that you implement the right constant for the right attributes in a table. It can help you to avoid such policies, right? So in the next segment, in this segment, we are going to spend some time trying to understand how do you design relational database. Before we understand how to design the relational database, we have to understand the concept that goes behind the design of the relational database, and that I can call as relational data model. So what is relational data model? It is nothing but designing the relational database. So you can think of a data model as a vocabulary or a collection of operations that help me design that particular database using a specific data model. So the data model that we will be using is called the relational database or relational data model, which is supported by lots of relational database products such as MySQL or Microsoft SQL or Oracle. These are the product that we use to perform SQL queries, or IBM DB2. All these are relational database management system because they all understand their relational data model, which is why even we have to understand what is relational data model if you have to work with relational database management system. So let us see what are the elements of the vocabulary of the relational data model. The first is that data is organized in the forms of tables and columns. This is very similar if you are familiar with Excel, right? So just like in Excel, we have the cells that are uh, there. There we have the rows and columns. So these are also in the relational data model. We call it as tables. So we can have for example, we can have table called an employee, and we can say that there are lots of attributes or columns associated with their employee table. For example, I have employee ID, I have name of the employee, and I have age of the employee. This is my table, and so on. These are all referred to as attributes or columns. So attribute is nothing but column. What is attribute? It's a column or column name. You can clearly see that the columns are actually vertically positioned and the data itself is organized in the forms of rows, right? So there are information about 100 employees that are being captured that will appear as 100 rows, exactly like you would see in Excel. For example, this is the most basic unit of information that is captured in a relational database. Uh, but then we say it does not, my database design does not end there. For example, it does not end by simply saying there's an employee table, there's a department table, there is another table. It does not like it is not like that. So we cannot simply say that I'll give you a list of tables and this is my database design. What we also want to be able to capture and convey are what are known as constraint, right? because we want to say that, what, you cannot simply blindly put whatever data you want in whatever table you want, right? So we say that let us put some rules behind what data can go inside a table, in what form, or what are the ways in which it cannot be constant. There are They are referred to as constant in the relational data model. Generally, when we talk about constant, we talk about this kinds of constant. One is called as entity constant, the next is called as referential constant, and third is called as semantic constant. So what do you mean by constraints? There are some rules that we put while doing the database design, right? So we'll try to understand each of these constant before we get into the actual design of a database. Entity constant. So the entity constant says that within the given table, what are the restrictions on the values of those attributes that you want to put. For example, in the employee table, we say that there's an employee ID attribute, there's a name attribute, and there's an age attribute. So entity constant, I want to specify that value of employee ID must not repeat within a table, right? So this is a constraint. I want to specify that value of employee ID must not repeat within that table, right? So this is a constraint, and in the relational data model, we express that this particular constraint by saying that this attribute is unique. So we say that this is a uniqueness constraint. We say that this is a uniqueness constraint by saying that this is the attribute is unique. So we say that this is a uniqueness constant as far as particular table is concerned or concerned, right? So what is worth noting over here is that we should be very careful in choosing in which attribute uh, get impacted by this particular constraint. So here in this example, we are saying employee ID is one or is the one which is unique, right? So for the two people to have the same name, so we should not be specifying uniqueness constraint uh, on the name attribute, right? In other words, there are no hard and fast rule imposed by the data model itself saying that what should be made as unique, what should not be made as unique. It is entirely up to your application to figure that out. On the other hand, instead of employee, if this happened to be a product table, for example, in that case, you might want to say that product ID user is unique and the product name is also unique, right? So just because it is a name, it does not mean that it should always be unique, nor it does mean that it should never be unique, right? So depending upon your application, you have to specify your constraint. You can also see that, for example, age, right? There can be multiple people having same age. Yes or no? There can be multiple people having same age, right? Or there can be multiple people having same name, which is perfectly fine. So you don't say anything. So in the design, you if you don't specify any constraint, it means that it can take any values. That is why it is called as a constraint. Constraint says you bind the values, you limit the values it in a certain way. So that is called as uniqueness constraint for you. This is your uniqueness constraint. Even more a little strict on the stricter side. What if I want to say that I want the employee ID, I want the employee ID, I want my employee ID uh, not only to be unique, but I also want to ensure that every employee is having an employee ID. Every employee is having an employee ID. I want to ensure this must have employee ID. Every employee must have employee ID. So you may be wondering that what is the difference between these two requirements, right? So for ease of understanding, let us assume that we are giving employee IDs based on serial numbers, right? We can have employee ID 1, E01, E02, E03, right? And so on. Suppose there are 100 employees. So one of the requirement that the uniqueness constraint says that the number is appearing in the column should never repeat. It is not necessarily saying it should be 1 to 100, but it has to be unique. But imagine this particular situation. Imagine a situation wherein I'm sure all of you are working professional. So if you're joining a company and on day one, when you enter the company with your documents, with your for joining, you would be surprised that your data is all here in their employee table except your employee ID. Obviously, they don't assign employee ID until you finish the joining formalities, right? So there is a little gap between assigning the employee ID and where you are about to join, right? So in order to accommodate data into a table, I will say as long as the value is assigned, it has to be unique, but it is okay not to be assigned yet. Then we said there are 100 employees already there and 101 employee working in all my name. Is there my age? Uh, is there my other Aadhaar number or all other details? And there are their employee ID is vacant, left vacant. They are waiting for me to finish the verification process. So in this situation, we'll say that employee ID will carry a value what is known as null, right? If the employee is not joined the organization, but you might have his other details, name, age, Aadhaar number, city in which is from, something like that. But unless and until you don't have his you don't have its joining formalities completed, you cannot assign the employee ID to that particular employee, right? So you can keep that as a null. So null value is acceptable value when the column is having unique constraint, right? When the column is having uniqueness constraint. So I'll tell you something which is slightly counterintuitive. There is 102nd employee, suppose, and who is walking in all along with your badge. So that employee will get initially an employee ID of null because he has not done formalities of joining, or he has not got the department in which he is. It is a violation of my uniqueness constraint that will get an employee ID as null. So you may be wondering, so we have two people having null values. This is 101 employee and this is 102 employee, right? Is that a violation of my uniqueness constraint? Fortunately, data relational data model relational data model does not is quite safe on that one. It says that it is a uniqueness applies to non-null values only. So you can have any number of employees with null values. So even though you have two null values, it does not violate your uniqueness constraint. Is that making sense to you guys now, everyone? Yeah.
Yes, sir.
So this is does not violate your null uniqueness constraint. Even though you have two null, it does not mean that it is not a unique, right? So this uniqueness applies to only non-null values. So you can have any number of employees with null values. That is still not a violation of the uniqueness constraint as long as the non-null values for that particular column are unique. Now suppose I want to put an additional constraint saying that I want, let us go to the product example. In product example, we have product ID, we have product name. So in there, I want to have a slightly different constraint. I can say I want to say that what it may be in the employee example. It is possible that employee ID can not exist until they finish the joining formalities. But I don't think product names are like that. When I'm entering information about the product names into my system, I want them to be unique and I want them to exist, which implies that I don't want to take any null values, right? So one way of saying that is the product name must be unique and should not take null values under the entity constraint. There's a nice shortcut available to say that the is a primary key. When I designate a column as primary key, what it means is that it has to be unique and it cannot be null. So suppose I have another table which is product table, in which I have product name. So I cannot have, let's say I have some product like washing machine, I have some product like refrigerator, and I have some product like air conditioning or something like that. I cannot have null, right? I cannot add a product name. It should not be null. So what do you mean by this? Product name is your, it should be unique. It should not be null. And this unique and not null is known as primary key. This is something which is very important. So if you might have heard about this concept that there is something which is known as primary key, which means that it is a unique and it is not null, right? So forget two nulls. Even one null is not allowed in this primary key constraint. It can never be that. It can never be there. So the constraint, so the primary key constraint, which is abbreviated as PK constraint, you can think it as PK constraint as a special case of a unique key constraint, wherein we are putting an additional restriction saying that it has to be unique and it should not be null, so that it is a entity integrity constraint. So unique and not null means entity integrity constraint, right? So we have seen all the entity constraint which is unique and not null, and we have seen the primary key, right? Now next is your referential constraint, second type. What is second type, which we already have discussed? There are three types of constraint, right? Okay, there are three types of constraint: entity constraint. Second is referential constraint, and third is semantic constraint. I think I have written this now somewhere. This one. So there are three types of constraint in your database or relational data model. So one is discussed first. Now let us discuss the second, which is referential constraint. Referential constraint. So what is referential constraint? Let us now try to understand referential constraint. Referential constraint come into play when you want to constrain the values taken by a column in one table based on the values that exist in another table. Now let us take two tables called as employee and department. So the employee has got employee table, has got attributes like employee ID, name, and uh, uh, employee ID, name, and their age. And there is another table we have, which is department table. This is the employee table. This is department table. So let us take department over here. And we have department ID, name, and address of the department, right? So the department table has got department ID, department name, and so we can already specify uniqueness constant as part of my entity constraint. I could have said that employee ID is actually a primary key. For example, if I can guarantee that it will never be null, and then I there are no other constant that I've put so far. If I don't put any other constant, what I can do is I can enter whatever values as part of the employee table. and for all attributes including employee ID, its name, and department ID. Suppose in this particular example that you are seeing, you will see that there are two rows in this employee table. There are two rows, employee 01, E01, E02, and you can see that the department ID that is used in this example is D04 and D01 suppose. So इनका डिपार्टमेंट यहाँ पे सपोज if I want to add department for this employee, so it is D01 and D04. In general, sometimes that you want to say that the attribute the attribute values of a certain columns should not take any value that is permitted, but I want to constrain it. In this particular example, I want to ensure that employees are assigned to only those departments that exist, and the departments that exist is mentioned in another table called department here, which says there are three departments called D01, D02, and D04, which is finance, HR, and IT departments. So let me add some values over here for this tables. Let us add some values. Yeah. So we have employee 01. Its name is, let's say, any random name N001, N002. Department is D04 and D01. Department ID you have is D01, D02, D04. Name of the department is finance, HR, and IT, right? Finance, HR, and IT. So in this particular example that you're seeing, you will see that there are two rows in the employee table. There are two rows, E01 and E02, and there are two departments. D01 referred to as finance, and D04 refers to as IT. So how do you specify this constraint? So this type of a constraint is referred to as referential integrity constraint, which means that I'm putting a constraint on what values as specific column can take based on the values that already exist in some other table. That is why in this example, let's say there be any number of employees, all the employees must necessarily belongs to these three departments. Or in other words, the attributes values, if you look at the values that are available in the department ID table, it should be one of those three values, so that it is referred to as reference integrity constant. Now let me introduce new terminology for you. So the attribute which is getting constrained is referred to as foreign key in this example. So in this example, this is referred to as department ID. So there is something which is known as foreign key, which is your department. So foreign key is a key which is already exist in the another table, which is over here, this one, right? So foreign key, why it is called as foreign key? Because this happens to be a key of some other table. So this is referencing a key of the department table. That is why this is the department ID in the employee table is referred to as the foreign key. So whenever we are specifying foreign key, we, unlike the primary key or uniqueness key, you can just specify, you can circulate, you can underline it and says it as primary key. You cannot blindly say that this attribute is a foreign key. What you have to say is department ID of an employee is a foreign key, which references the department table, right? To be more specific, which references the primary key of the department table. So department ID, this department ID or this department, suppose, is a foreign key, but that is a primary key in another table, which is department table. Yes or no? Once you add that constraint, then when you are using that particular database, the database will give you an error when you're trying to insert a row which is having a department ID which is absent in the department table. Let's say if you want to add D05, which is not there in your department table, so it will throw the error, right? It will throw the error because it does not exist in your department table. So we already talk about unique key. We already talk about the primary key. We already talk about the foreign key. Just to confuse a little bit, let us understand. Let me throw some comparison between these keys, right? To begin with, foreign key is not a key at all, because what is the characteristics of a key? It has to be unique. You can clearly see that there can be more than one employee with belonging to the same department. I can have another employee which belongs to D01, D04, and something like that. So it is not a unique, right? So it's not a key. What to be in relational data model, to be a key, it has to be unique, first of all. So this department is not a unique. So it's not a, the foreign key is not a key at all. I can add new row employee 03 who works in the same department, department number 1. And so foreign key need not necessarily to be unique key. So foreign key need not be unique. We can have an additional constant that that it has to be unique under circumstances. But this does not mean that foreign key is unique, right? So that is difference number 1. Foreign key is not unique. Difference between foreign key and primary key. Foreign key and primary key. Foreign key is not unique. Primary key is unique. It's not unique. This has to be unique, right? Then second difference. Primary key, comparing it with the foreign key. Primary key, for any table there can exist only one primary key. So you can have to make up your mind that what is that single attribute which will never be empty or null, and which will always be unique. You have to identify that, right? So every table can have exactly one primary key, whereas given table can have any number of foreign keys. If I go back to the employee table, I can have another foreign key which talks about the branch to which I belong to. So that can be a foreign key which references another table, can called as a branch table, correct? So that is the second difference for you, which means a primary key can, there can be only one primary key, but foreign key can take any number of, a table can take any number of foreign key. Table can take any number of foreign key, right? In other words, what we are saying is table can reference many other tables, right? So that is another very important difference, of course. If you compare it with unique key, and single table can have any number of unique keys. You can say name is unique, you can say mobile number is unique in that particular table, you can specify any number of unique keys. But as far as keys, primary key is concerned, there can be only one primary key and any number of foreign key. One last thing I want to mention is with respect to foreign key. The foreign key says that it has to reference the column of another table which happens to be a primary key. That alone is not sufficient. The value that I'm actually inserting into the employee table, that department must be existing in already in the department table. For example, suppose I'm creating new department, right, called as estate management. Let's say department 05. We have estate management. So I know that is going to be a department number 05. It is just stuck in some approval process. But then I already have lined up people to join that particular department. So what I cannot say is, I cannot say the employee number 04 who is joining with this into the company. This company is going to be in the department 05. And now you cannot say that what department are I, right? You cannot say department 05 is not there, what department are I. So it should not be like this. We cannot say that, which means we have to have, if that in case, we have to insert a row department 05 into department table first before you can designate somebody in the database as belonging to department 05, which means the foreign key restriction not only is not only referencing an attribute, but the specific attribute values that are existing at that point of time. So if you really run up and end up in this kind of situation where then you can manage this piece of information outside of the system only after you get the necessary authorization to insert a row department number 05, should add employees belonging to that particular department. Of course, a small workaround I can give you. The small workaround is that you can insert initially the employee into database and put a null values for that specific branch, right? Because D05 does not exist yet, you can initially store it as null values so that it gives me one more difference between primary key and foreign key. That is nothing but foreign key can take null values, but primary key can never take null values. Right? So this is your difference between primary key and foreign key. So initially, I will put it as once the department gets created, once that rows gets inserted into table, then I can go back to the specific employee, and then I can update the employee's branch ID to 05, D05, and I'll add this into this table first, and then I can update keyboard department here already, mere paas. So I can add this. So that is referential integrity for you, which is implemented using this term called foreign key. Now is it clear for you, everyone?
Yes, sir.
Yes.
Yeah. So you go through one more time, go through this one more time. We are still left with semantic constant entity relationship diagram and star schema demonstration before actually moving into practical implementation of Excel, SQL. So if you observe, I could have directly started this just by saying, just by directly installing SQL and directly having uh, just like what other people teach, right? If you go to other institution, they teach you a skill from this thing. How do you create a table? So we directly install the SQL. They don't teach you at all about database, online analytical processing, what is why there is need of constraints, what is star schema, what is entity relationship diagram. They directly put you through in this situation. You have to install this and directly you have to start creating table and something like that. That is not needed. You should know why there is need of uh, your why what is data warehouse, what is the difference between transactional database and data warehouse. You should know this, then only you will be able to relate this fact that why there is need of SQL, right?
Yes.
Uh, all right, so I'm sharing this file. You go through this one more time. This is sufficient for you. Apart from this, if you just are interested, you can download this as a offline material, and you can write down your notes somewhere down the line. Suppose for an example, you want to write down some points related to this as part of your notes, so you can create notes like this. So whenever you want to revise this concept, you should not go through the recording, you should go through this sheet that you have created. So first time revision is good. You can go through recording once, twice, or thrice. But apart from that, it is very time consuming, right? To go through the recording, you have to spend your 1 hour time. But uh, if you just cut down that time to, let's say, 50 to 20 minutes by just writing down few important point in the sheet itself, that will be good for you. So like that, you have to minimize your revision time or minimize your work. Like that, you have to do.
People, where we can get this drive?
Which
Just
drive?
now, just now you uploaded, everything in this drive only. Where we can get?
Is this your first lecture?
No,
Then how many times you are going to ask this? I can expect this question from Lakshmi and uh, Vijay, but this is not your first session, no? I've
no.
told you to bookmark this again and again, but you are not doing this thing. See, this is your drive link. What you have to do is, I'll share it once, one time, two times, three times. That is fine. But every time if you ask me, you have to share this. I'll not be sharing this. So instead of this, what I'll suggest you is you go through this and just bookmark this tab, which will be helpful for you, even though if your classes are finished,
Okay.
right? Yes, Supriya. Now, do
Ah,
you remember I've shared this multiple times before?
yes, once you share it.
Not once, I've shared it multiple times. You only asked me twice or thrice. Can you just bookmark this? Yeah,
Yes.
just bookmark this. Make sure you are not, you have that in your record. See, if I just, if we end up in this meeting, you'll not be able to access that link. That's the reason why I'm focusing this again and again, that you should bookmark this. If I end this meet, this will be gone, right? Make sure you bookmark this. All right, then. Do you have any questions apart from this?
No issues.
No.
All right. Thank you, everyone. Bye.
Thank you. Bye bye.
Thank you.